Welcome back, class. This is Mr. Smith, and this is 1.27 completing the square. Like I said, I was going to teach you how to do this. I didn't do it last lesson. That's why we're doing it this lesson. Factoring a perfect square is actually really easy. A trinomial that factors into a binomial multiplied by itself is called a perfect square trinomial. And here we actually have a few examples. If we factor these using our methods that we used before, so we could use MAN just really quickly so that we can see what multiplies to 1 adds to 2. Our numbers should be 1 and 1. And that basically is what this means, is that it's going to factor and have the same number. So it should be x plus 1 and x plus 1. Which just means this is x plus 1 squared. Just ignore that bracket. For some reason, my stylus does that. In our next example, we have x squared plus 6x plus 9, which means we're going to multiply to 9, add to 6, and our numbers are, well, you tell me. If you said 3 and 3, you are correct. There's only one. X plus 3, x plus 3. And that means that this is just x plus 3 squared. Same idea. Moving on to the next one. Multiplies to 25. Adds to negative 10. Our numbers are what? If you said negative 5, you are correct. We have negative 5 twice. So if you said x minus 5 times x minus 5, you're good, which is really just x minus 5 squared. Pretty straightforward stuff, not overly complicated. And in our next set of questions, we actually have determined the value of c that makes a perfect trinomial, or makes a trinomial a perfect square. And in this case, c is always equal to half of b squared. So c always equals b divided by 2 squared. So you can actually use this to solve for each of these. So if we have c equals 24 over 2, and then square it, we'll actually get what the c value is. 24 divided by 2 is 12. 12 squared, you should get 144. Same idea for the next one. If we have c equals negative 4 divided by 2 squared, well, negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Next example, we have negative x squared minus 16x plus c. So our c value is going to equal negative 16 over 2. Again, and you square it. Negative 16 divided by 2 is 8. 8 squared is 64. Sorry, negative 8. Negative 8 squared is 64. Okay. So that's pretty straightforward stuff. Now you know what a perfect square is. There's different things we can do with it, different methods. So if I go on to the next slide, we'll see kind of how this develops. Now I'm back. Okay, for completing the square and using the method to complete the square, you convert from standard form to vertex form. And the way you actually do this is, while it's explained here with a bunch of letters, it's going to make a lot more sense once I get into an example here. So for completing the square, the first thing you do is you take out a factor of a from a and b, and you end up with this line here. You have a bracket x squared plus dx plus c. So the d is actually just b divided by a because you took out a factor of a. Next, you take e, and the reason why that the second line works is because positive e minus e is just equal to 0, right? You're just adding 0 to it, so you're not effectively changing it. And this e value comes from half of whatever d is. So after you take out a factor of a from both a and b, the first and second terms, you get this value d, because d is b divided by 2, or divided by a. Then you divide d by 2 and square it, and that's where you get e. So divide d by 2, square it, and that's what e is. And you add it and subtract it. And when you add and subtract it, you're really just effectively adding 0. Then to finally go to your third step, you're going to factor using perfect squares, because e, so it'll be x squared plus dx plus e will be a perfect square. However, you got to get rid of that negative e, and that's where the tricky part comes in. That's how we get g. G is really negative e times a, because you had to take the negative e, multiply it by a, and then subtract it or add it to c. So when you take the negative e term out of that line there, you have to multiply it by a, and then you add it to c. This might seem like a lot to take in. The f value, sorry, I missed that. The f value in the brackets here, that's just after you factor it and you get your perfect square, like we saw in the last slide. Very, very easy once you get to that point. The trickiest part, I would say, is getting that g value. There's a lot of letters here, and I think it makes a lot more sense once I'm getting into an actual example. So let's just dive into that first. So here, let's get started. We have x squared minus 8x plus 9. I'm going to take out a factor of 1 because that's what my a value is. Then I'm left with x squared plus dx. Remember, d is just the b value, which is negative 8. So this will actually just be minus 8x. You could have just wrote negative 8x and bracket plus c. What's my c value? 9 is my c value. Okay, now we're going to create these e values. Remember, e is half of negative 8 squared. So what's half of negative 8 squared? We're going to bring this back. You don't have to write the 1. We'll have x squared minus 8x, then half of 8 squared. So half of 8 is 4. 4 squared is 16. So we're going to add 16 and subtract 16. So plus 16 minus 16. And then we have plus 9 here. Okay. And what we actually do here is, for these terms in here, I'm actually just going to use factoring, because it's a perfect square. We factor it, and I'm left with x minus 4 squared, right? You can use the man method for this, or because you know it's a perfect square, because that's how we set it up so that it would be a perfect square, we're okay. We can just jump to that step. Now, I didn't evaluate the negative 16. The negative 16 has to multiply by the a value, but the a value is 1. So negative 16 times 1 is just negative 16. So now we can move it out of the brackets. Remember, I multiplied it by 1. So now I have negative 16 plus 9. And now we can simplify this, and we should get our vertex form. So our vertex form is x minus 4 squared minus 7. There we go. And that's how you solve or find vertex form, by completing the square. It is a lot to take in, so take your time with this. Okay, same idea again. Put brackets around the first two terms. We're going to take out a factor of a, which is 2. And we're left with 8x. Or we're left with x squared plus 6x, right? Because we took out a factor of 2 plus 13 here. Now we need to add half of the b value squared, or the d value squared. Our d value is 6. So if I have 2 here, this becomes x squared plus 6x. Half of 6 squared. So half of 6 is 3. Square it, you get 9. So you add 9. Plus 9 minus 9. And I effectively just added 0, because plus 9 minus 9 is 0. Okay. Now we're going to factor the first 3 terms. I'm going to use a different color. I think that a different color might help illustrate this. I'll use red to factor. If I have 2, and then in brackets, x squared plus 6x plus 9, it's just x plus 3 squared, right? Because 3 and 3 will multiply to positive 9 and add to positive 6. Okay, so I factored that. Now I can go back to, let's use green for this. I need to get rid of this negative 9. So on my aside here, in green, I had negative 9, but I have to multiply it by a, so it has to be times 2, which is just negative 18. Okay, so we have negative 18 outside the brackets, because you have to multiply that negative value by the a value to get negative 18. Then you're left with just the positive 13 at the end. And now we just simplify. And when we simplify, we have 2x plus 3 squared minus 18 plus 13 is just minus 5. Subtract 5. There we go. And that's all there is to it. Hopefully this is starting to get more familiar. We got one more example, and we'll take it slow again. And I am back. Okay. For this example, we have find the vertex. If you have the notes printed out, there is an error somewhere in the notes. This should be positive, a positive b value, so you should have negative 2x squared plus 8x subtract 2. And the reason for that is we already have the graph. It's just that when we work this out, we actually get a different graph. Otherwise, I would just change the graph and make it all work out. But in this case, the graph is already computer generated, and it's going to be a lot nicer than what I can do. So we're just going to change the notes. So make sure that that's plus 8x. Okay. So moving on, I'm going to take out a factor of negative 2. I'm not going to rewrite this. So after I take out a factor of negative 2, I'm left with x squared minus 4x, and then minus 2 outside the brackets there. And it's negative 4x because positive 8x divided by negative 2 becomes a negative 4x. Okay. Now we're going to make this into a perfect square. Remember, it's half of that second value squared. So half of negative 4 is negative 2. Then we square it. Let me just write this out. So half of negative 4 is negative 2. Square, it's positive 4. So we plus 4 minus 4. Because then we're effectively just adding 0. If you add 0, you don't change the question. So we're allowed to do that. Now we factor what's in the first 3 terms inside the brackets. If you factor it, you should end up, let me just underline it in red, make sure that we're all on the same page here. What adds to negative 4 but multiplies to positive 4? If you said negative 2 twice, you are correct. So x minus 2 squared. There we go. Then let's use green. I need to move that negative 4 out. Remember, negative 4 times negative 2, because this is our a value, this is our e value, our negative e. Make sure this is our side here. Negative 4 times negative 2 is just positive 8. So then we move that positive 8 outside of the brackets. We write it right there. Then we are left with our negative 2 at the end. So finally we simplify. Negative 2 times x minus 2 squared plus 6. Perfect. Now we just need to know what our vertex is. Well, our vertex, luckily, is given to us. Our vertex is positive 2 because x minus 2 needs to be equal to 0 to give us our x value of our vertex, and then positive 6 here. So we have 2, 6. It opens down because our a value is negative, and our step pattern, well, instead of 1, 3, 5, it should be 2, 6, 10, because our a value is negative 2, which means it's opening down, but it's also stretching it vertically. Okay, so let's plot our vertex. 2, 6 up here, and then over 1, down 2 right here, and reflected, then over 1, down 6. What is that? 1, 2, 3, 4, 5, 6. So 2, 6, and then 10. So reflect that over here. And 10 won't fit. Okay, and then we just graph it. And your graph should look something like that. You can plug it into Desmos and see. I checked over the notes again. The graph and the equation were both wrong and mismatched. Just go with this graph for now. I know it's not the prettiest thing in the world, but do your best to try and make it as round as possible. With that said, you should know enough now to do assignment 1.27. This does tie a lot together. It ties in together vertex form, it ties in graphing, it also ties in factoring. So this should help you review and solidify all those key concepts and understanding quadratic equations. If you are struggling with something, don't hesitate to ask. Make sure that you work through it. I am going to do a summative assessment in about 2 weeks. So best of luck, and I hopefully will hear from you. Make sure you post on Brightspace if you have any questions.